This project on bridging the learning gap between on-campus and online students is presented by Dr. Badri Basnet and Dr. Ernest Dunwoody. The problem is that there's been a big increase in demand for online study in technical fields such as geographic information systems. At USQ, this has increased tenfold in the last 10 years. This requires a hands-on skill to be learnt in GIS, but providing such a skill online is quite difficult. Bringing students to campus defeats the purpose of making it online, and asking students to buy their own learning system is not equitable. So the learning and teaching inequity between the study models is a real issue. The benefits and constraints for online students are that it's convenient and flexible, but there is limited learning support, there's no access to lab facilities, and there's a need to attend a residential school. And for the institutions, in order to provide hands-on learning technologies to online students, they need to conduct a residential school, which costs extra money and effort and is a constraint for these online students to attend it. So there is inequity between the study modes. This project aims at addressing this challenge. So the aim of the project was to provide a GIS learning tool and learning resources that are readily available, affordable, flexible, learning effective, user-friendly, and equitable. To do this, the objectives were first to select a GIS software that met the stated aim. Secondly, develop hands-on learning resources for the selected software. Thirdly, to offer equitable, affordable, and flexible learning resources. And fourthly, to maintain user-friendliness and learning effectiveness of the resources. This was done by using the introductory GIS course as a test bed. For Objective 1, we selected appropriate GIS software. For Objective 2, we identified the required learning resources and development methods to support the theory and the software. Thirdly, we chose resources that met the required qualities. And fourthly, we validated and realigned the resources. The project outcomes were the result of a free and open source GIS software was selected, audio-visual demonstration videos were made, problem-based learning exercises, questions and answers for each video were prepared, the assessment items requiring GIS software use, and frequently asked questions, a question bank, and a comprehensive list of hands-on learning resources were prepared. So the benefits were that there was a hands-on learning opportunity for the students and online teaching resources for the institution, which saved both the students and the institution's time and money, and also provided motivation for others in the other GIS courses. At the end of each semester, we conducted a survey and found that almost all the students used the recommended software. Again, almost all the students used the recommended assistance resources that we provided for them, and most of the students made a commitment that they would be or plan to use the software in the future. The last part of the assessment was whether or not they found the learning resources helpful or very helpful, and almost all students agreed that they were a lot of assistance to them. We thank you for listening to our project.